Okay, these are some more problems from 4.2, and these are just antiderivatives, so these are pretty straightforward. This is number 35, and the notation was a little different in the book, so I just told you to kind of write it like this. This is f of x, and we're going to be looking for capital F of x, or the antiderivative, that's all. And we have a point that it goes through, so we'll be able to determine what the c is in this case. So this was my function, f of x, and I'm looking for a capital F of x that's antiderivative. So f of x equals negative 1 over x squared. X is greater than 0, so we don't have to worry about undefined points. And then the point that belongs to the actual function, f of x, the antiderivative that is going to be 2, 1. So if we take the antiderivative of this, we know from our formulas that's just going to be 1 over x. And it's really easy to check what's the derivative of 1 over x. Negative 1 over x squared plus c, so that's the antiderivative. But we know that f of 2 is 1. This is the x, this is the y, so this is f of 2, which is equal to y. That equals to 1. So we just rewrite this. Instead of f of x, we write f of 2. Instead of writing x, I put 2. So f of 2 equals 1/2. So you can see that, that's 1/2. Okay. 1/2 plus c. But what was f of 2? F of 2 was 1, so I put 1 in here. So I've got 1 equals 1/2 plus c. If I subtract 1/2 from both sides, I get 1/2 equals c. That implies that f of x equals, again, 1 over x plus c, which is 1/2. Okay. Okay, number 36. Okay, this is what we have here. F of x is 1 over 4 times x to the 3/4. So I'll just put the x to the 3/4 up on the top. That'd be a little bit easier to take the antiderivative, and this point 1, negative 2 belongs to the antiderivative, capital F of x. So let's take that antiderivative. And that's just going to be 1/4, and I add 1 to 3/4 and divide by that. So if I add 4/4 to 3/4, I get 1/4, and I divide by 1/4, and then plus c. But 1/4 over 1/4, these just become 1. So I just have x to the 1/4 plus c, but I know that f of 1 is equal to 2 because the point, negative 2, because the point 1, negative 2 belongs to the function. So f of 1, I can just rewrite this as f of 1. And that's going to be, instead of x, that'll be 1 to the 1/4 plus c, which is just 1 plus c. But what was f of 1? F of 1 is negative 2. And then if I subtract 1 from both sides, I get negative 3 equals c, and that implies that f of x equals x to the 1/4 plus c, which is negative 3, so x to the 1/4 minus 3. Okay? All right, that's number 36. Let's try number 37. Okay, 37, f of x equals 1 over x plus 2. X is greater than negative 2. There's a reason for that. We're going to see in just a second. Kind of give you an indication that we're going to probably take the natural log. This point, negative 1, 3 belongs to f of x, big F of x. All right. Okay, so again, if this looks like it's 1 over u du, or just 1 over x in this case, or 1 over u du, the derivative of that is just 1. So I tried natural log of x plus 2. And it's really easy to check it. What's the derivative of the natural log of x plus 2? 1 over x plus 2 times 1. No problem. Plus c. Okay? So that was my antiderivative in the general form, but I do have I have a point, so I can find a particular solution. So I'll put f of negative 1 equals the natural log of, instead of writing x, I write negative 1 plus 2 plus c. And 2 minus 1 is 1, so I have, and the f of negative 1 is 3, so I can put the 3 there. And the natural log of 1, e raised to what power is 1? Remember, e, that's base e. E raised to what power is 1? Well, 0. E to the 0 is 1, so this is going to be 0. So that's 0. So 3 equals c. That implies that f of x equals the natural log of x plus 2 plus c, which is plus 3. So there you go. All right, and the last one, number 38. Here's number 38. Let me finish this. F of x equals 2x plus 1 minus cosine of x. P, the point 0,3 belongs to f of x. So when I take the antiderivative, this is just going to be x squared plus x, and the antiderivative of the cosine of x is the sine of x plus c. You can always check it. The derivative of x squared is 2x. The derivative of x is 1. The derivative of, there's negative, and the derivative of the sine is the cosine, and the derivative of a constant is 0, so it checks out. So there's our antiderivative. And we know that f of 0 equals 3, so I put f of 0, and every time I see an x, I put a 0. So 0 squared plus 0, and sine of 0 and plus c. But sine of 0 is 0, so these are all 0, so I just end up with f of 0, which is 3, equals c. So my antiderivative would be capital F of x equals x squared plus x minus sine of x, and instead of c, I can write 3. So those are all pretty straightforward and should have been easy. So I hope those help.